Yes, Simra, Neha, am I audible?
Yes, ma'am. Good evening, ma'am.
Yes, ma'am.
Okay, good evening, class. So yesterday we started with it, vectors with number, vectors with scalars, and vectors with vectors. Okay, let's start with the dot product. Now, dot product is the scalar product. Scalar product means the resultant will be scalar. You will have two vectors only, one vector, two vector. When you will take their dot product, the resultant will be a scalar. For example, right now you are not you must have heard somewhere, but the formulas you must not be very much aware. But I'll give you certain examples from the class 11th. Okay, force, it's a vector. Dot velocity, it's a vector. F dot v will give you power. Power is scalar. Okay. Or one more example. Force is a vector. Displacement is a vector. Force dot product of force and displacement, both of them which are vectors, will give you work done, which is a scalar quantity. So this is how your vectors are applied. See, this is a vector, but result is a scalar. This is a vector, this is a vector, but result is a scalar. That's how you use it. This is one vector A, this is one vector B, angle between them is theta. So when you write the dot product of these A dot B, how to solve it? Take the magnitude of the vector A, take the magnitude of the vector B, and take the cosine of the angle. That is cos theta. Magnitude of A, magnitude of A. So you can say A dot B is simply AB cos theta. Okay. Or let's look at an example. Let's say we have to get V1 dot V2. So V1 is 5, V2. What will it be?
3. 3.
3.
3.
Yes. Yes. Because we don't take the sign, because we are taking the magnitude, right? So it will be 3 into cos 60 degree. So this will be 5 into 3 into cos 60 is half. So this is 15. That is 7.5 meter per second. This is the resultant of V1 dot V2. But there are various properties which you should keep it in mind. Write it down, then let me start with the properties. This basics is clear. What is the actual formula in the polar form? Yeah?
Yes, ma'am.
Yes, ma'am. Clear.
Okay. Okay, please write it. Okay, let's come to the properties now. See, first property, as we discussed, result will always be a scalar quantity. Like you can have the example, best example is you can take any two dot products between any two quantities which are coming. Many quantities are there in your class 12th also. In class 12th also, same properties will be applied. So when you have work done you will be doing in the fifth chapter, work, energy, and power. It is force into displacement. So like this, so result will always be a scalar, the resultant. It is commutative. Commutative means if I have A dot B, I can write this as B dot A. It's fine. Like commutative property is applicable in your addition and multiplication, right? 3 plus 2 is 2 plus 3. I can reverse it. In addition, in a multiplication also, 3 into 2 and 2 into 3. But if you have division or subtraction, you cannot reverse it. 3 minus 2 and 2 minus 3 are not the same. Right? 3 divided by 2, 2 divided by 3 are not the same. So this is commutative. This follows commutative property. Then perpendicular vectors. See, vector along x axis is I cap. The vector along the y axis is j cap, and vector along the z axis is k cap. So if you take all the perpendicular vectors perpendicular to each other, any of the two, j dot k dot I dot j, I dot k, anything, see, all of them will always have this angle 90 degree. And here when you will have I dot j, let's say, for example, when you have I dot j, so this will be I cap, j cap, magnitude of them into cos 90 degree. That is 1 into 1 into 0. Magnitude of I cap and j cap are 1 because they are unit vectors. So I cap magnitude, j cap's magnitude, cos 90. So answer will be straight away C. That's why all these perpendicular vectors, I dot j cap dot k cap dot I cap, they are always 90 degree. So at each other. So answer is always a 0. Is this point clear? Why it is 0?
Yes. Yes, ma'am, clear.
Okay. But if we take the parallel vectors, like I cap with I cap, if we take it with I cap, or when you're taking j cap with j cap, so they are parallel, means they have the angle 0 degree to each other, right? So what will it be? Let's take an example. Let's say I cap dot I cap. Magnitude 1 into cos 0 degree, which is also equal to 1. So when you have these, the resultant is always 1. So you have I cap dot I cap, which is equal to j cap dot j cap equal to k cap dot k cap equal to 1. Okay. Last property is, see, when you take two exactly same vectors. So see, when you take the same vectors, A dot A or anything, they are actually parallel to each other. This was for the universal. Same rule is valid for any two vectors also which are parallel to each other. A's magnitude into A's magnitude into cos 0. Cos 0 will be 1. Why 0? Because they are identical. This is the case when the vectors are identical. In this final property, vectors are identical. Okay, vectors are identical to each other. When two vectors are identical to each other, their resultant A dot A will also have A square. It will become A square, right? Because they are parallel. Okay, and this was just an example like f dot h. If theta is 0, cos 0 is 1. This is just an example of the dot product, which I have discussed before this also. Then we'll come to Cartesian form and then we'll practice questions, but write down the properties.
For perpendicular vector also, then we can write I cap into j cap is equal to j cap into k cap, which is all equal to 0.
All
The
equal
same
to 0.
statement as
Exactly. Yes, yes. Same statement like the parallel ones. Okay, see, let's come to the dot product in the Cartesian form. A vector is there, B vector is there. So all the coefficients are present the way we add in the Cartesian form. Remember when we had unit vectors, we added. How did we add it? A1 plus B1, A2 plus B2, A3 plus B3. Here also you're just going to multiply them. That's it. And I dot I is 1. So you need not write it. It will get vanished because it's 1. So here also multiply these two, multiply these two. So A dot B will be A1 into B1 plus, no need to write I cap this time because I cap dot I cap will be 1 only. So that's hidden always. Plus A2 B2 plus A3 B3. Not A1 into B1 whole I cap the way we used to write it in addition. Here you will get one complete final answer. Like let's say this is an example. A is 3I cap minus 3J cap plus 4K cap. B is I cap minus J cap minus K cap. So when we write A dot B, this will be 3 into 1 plus minus 3 into minus 1 plus 4 into minus 1. So this is 3. This is also 3. And this is minus 4. So this is. So here you won't get I cap, J cap or anything fixed. Okay, because you're going to simplify it, you're going to solve the answers. You'll get a final value. Like in the addition, when if I say add these two, you will say answer is 4I cap minus 4J cap minus 3K cap. Right? You will get it in terms of I cap, J cap, K cap. Here you will get the proper value because you are multiplying them. Okay, write it till here. Try this question just once, then I'll discuss it with you. Okay. That's all there in the dot product. These are the only things that we need to solve. Okay, first write down this one. Okay, let me discuss it now. See, you have a force 2I cap plus 3J cap minus 5K cap. It displaces the body from point A 2, 3, 0 to a point B, that is 4, 2, 1. If you have the coordinates, see, you know what are these coordinates. This is X, this is Y, this is Z. So you write RA as 2I cap plus 3J cap plus 0K cap, which is equal to 2I cap plus 3J cap. Then you have RB, which is 4I cap plus 2J cap plus 1K cap. This 1K cap you can write it as only K cap. These are the separations. So you need to get the separation, means this is one point, this is second point. You need to get the difference between both the points. Okay. So your RAB will be RA minus RB. Okay, RA minus RB. What's the initial point? From A to B. So it will be RBA. Final minus initial will come. So this will be RBA. This will be RBA, RB minus RA. So RB is this 4I cap plus 2J cap plus K cap minus RA is 2I cap plus 3J cap. So when you subtract them, 4I cap minus 2I cap, 2I cap, 2J cap minus 3K cap minus K cap, and K cap minus 0 is plus K cap. So what is this? This is the position, RBA. What's the force? 2 plus 3 minus 5. 2I cap plus 3J cap minus 5K cap. Now work done is the dot product of force into this displacement. So you will multiply these, so it will be 2 into 2 plus minus 1 into 3 plus 1 into minus 5. So this becomes 4, this becomes minus 3, this becomes minus 5. This is minus 4 joules. This is the answer. Is it clear?
Yes,
Any
ma'am.
doubt? Anything you've not understood? I hope it's clear. We'll see some other kinds of questions. Write down the solution to this one. Yeah, Simra, any queries?
No,
Okay.
ma'am.
All right. Please write it. Okay, let's discuss. See, whenever you get a question, you have to calculate the angle between two quantities. Always use dot product, because with the help of dot product, you will at least get the cos theta, and it will ease your calculation. See, these are the two vectors. A dot B is equal to magnitude of A, magnitude of B, cos theta. From here we can say cos theta is equal to A vector dot B vector divided by the magnitude of A into magnitude of B. A dot B we have studied how to calculate. Let's calculate this first. First, let us find out A dot B vector. So it will be 1 into 1 from here, 1 into 1 plus 2 into minus 2 plus 3 into minus 5. Right? That's how we have studied to solve A dot B in Cartesian form. So this will be 1. This is minus 4. This is minus 15. This is minus 19. This is minus 18. So A dot B is minus 18. Let's say this is 1. Now magnitude of A. Magnitude of A will be under root of A is 1, 2, and 3, right? So it will be under root of 1 square plus 2 square plus 3 square. This will be 1 plus 4 plus 9, that is root 14. Let's say this is equation 2. Then you have to calculate the magnitude of B. So this will be 1 square plus minus 2 whole square and plus minus 5 whole square. So this becomes 1 plus 4 plus 25, right? This is 26, this is 30. See, this is the second equation. So see, you have all the three equations with you. What you have to do, you have to put it in the main equation. Main equation is this. Let's say this is third. 1, 2, 3, 4. 3 I have already written. Yeah, this is third one. Okay. So here this will be, when you put cos theta will be A dot B is minus 18 divided by magnitude of A is root 14 into this is root 30. So this is equal to minus 18 by root 420. So theta we can say cos inverse minus 18 by root 420. This is the, is that clear?
Yes, ma'am.
Oh, write it. Then we'll see just one more thing and it will complete the dot product part. Please write it down. Question you have written, I think, both of you. Okay, class. See, there is a concept of component of A along B. Sometimes this can be asked to you. You have the vector A1 I cap plus A2 J cap plus A3 K cap. B vector is there, B1 I cap plus B2 J cap plus B3 J cap. When you are asked to write the component of A along B, this means A vector dot B cap. A vector as it is, unit vector of B multiplied to the unit vector of B. This is the formula for it. There's a derivation for it which you need not do. Finally, the resultant will come out to be this. Or it says if the component of B along A. So B vector dot A cap into A cap. Like, let's discuss one question. This says component of A along B. As soon as it says component of A along B. So component of A is first, so B will come twice in the unit vector. So in the first part, you have component of A along B means A dot B cap into B cap. Okay, this is it. And if it was reversed, B is component along it. So B vector dot A cap into A cap. Now, here vector A is ready with us, so we need not do anything. But B cap is not there. So B cap we need to make. What's the formula of a unit vector?
B vector upon its magnitude.
Yes, very good, Simra. B vector divided by its magnitude. Correct. So we have the vector. Let's find out its magnitude. Magnitude of B will be under root 1 square plus minus 1 square plus minus 1 square, which is root 3. So B cap will be I cap minus J cap minus K cap divided by root 3. So when you have the component, it is also asked as projection of A on B. I'll write it here so that you remember. Projection of A on B. So vector A is I cap plus J cap minus 2K cap. I cap plus J cap minus 2K cap. Right? This is A. A dot this B I cap minus J cap minus K cap divided by root 3. Finally, when you will take their dot product, you will multiply it again with this I cap minus J cap minus K cap divided by root 3. So see, this is simply 1 into 1 plus 1 into, no, not 1 into 1. This root 3 is also there. 1 into 1 by root 3, right? This is 1 by root 3, the coefficient. Here it will be 1 into minus 1 by root 3. And this will be plus minus 2 into minus 1 by root 3. Multiplied to this whole term, I cap minus J cap minus K cap divided by root 3. So this becomes 1 by root 3. This becomes minus 1 by root 3. And this is plus 2 by root 3 multiplied to I cap minus J cap minus K cap divided by root 3. They'll get cancelled. So you are just left with 2 by root 3 multiplied to I cap minus J cap minus K cap by root 3. What's the final answer? 2I cap minus 2J cap minus 2K cap divided by 3. Right? Root 3 into root 3 will become 3. Or you can separate the terms. You can write 2I cap by 3 plus, no, minus. This will be minus 2J cap by 3 and this is minus 2K cap by 3. This is the component of A on B, a projection of A on B. Is that clear? Okay. Try the second part. This you will tell me, B on A. Okay, first write it from How much you are getting, Simran? 2 I cap plus 2j cap minus 4k cap by 6. Okay, Neha, what's your answer?
I'm still doing the ending part. I'm in 6 by root 6 into I cap minus
Okay, just do it.
that part.
Okay, just take 1 minute.
I got 6 I cap plus 6 j cap minus 12 k cap by root 6.
Minus 12 k cap by root
Yeah.
6.
Yeah.
Multiplying root with root, I think will change it. See, this was I cap plus 2j cap. I hope you all have used the second one. B vector dot A cap. See, what will be the A cap's value? A cap will be vector A I cap plus j cap minus 2 k cap divided by its magnitude. What is its magnitude coming? 4, 5, 6. Root 6. Huh? This is A cap. And you're multiplying it with the B vector. That is I cap minus j cap minus k cap into this whole term I cap plus j cap minus 2k cap. Neha, root 6 into root 6 will be 6 only. See, this will be 1 into this 1 by root 6. So 1 by root 6. This is minus 1 by root 6. This is plus 2 by root 6.
I
Simra's
took
answer is
A.
correct. You,
I did a mistake
Simra,
when
your
multiplying.
answer
Yeah.
is right. Correct. This will be 2 by root 6 into I cap plus j cap minus this 2k cap. Minus 2k cap by root 6. When you multiply it with 2, it will become 2I cap plus 2j cap minus 4k cap by 6. What was Simra's answer? 2I cap plus 2j cap minus 4. Neha, you have checked. What was the mistake, by the way? What did you do?
I took the vector A multiplication instead of vector B. I wrote
Okay,
I
use
cap
the
my
first
plus j
formula.
cap.
First formula.
No, instead I wrote the formula correct, but instead of
Okay.
substituting B,
While
vector B, I
substituting
put
it. Okay.
yeah.
Okay. See, what is the meaning of what when we say B vector dot A cap into A cap? The meaning, the metrical meaning is basically there's a vector A, there's a vector B. They both have an angle theta. So when we resolve it, yesterday we have studied resolution of vectors. So if I resolve A's component, I'll get A cos theta here, right? Similarly, when I have taken just the component here, A cos theta. So this A cos theta and this B, they are aligned together. See, this is what we write now, AB cos theta. That is what is meant by projection of A on B or component of A on B. So A dot B, which is AB cos theta, is justified from the geometrical diagram. Okay, why do we write projection of A on B and why do we write this? The reason is this only, that vector's projection means you have resolved it. Whatever is its component along that side, you have taken it. So from here only you have the formula AB cos theta. This is the reason we are considering it as cos theta. Okay. So geometrically, dot product of two vectors is the product of magnitude of one vector and projection of the other. So projection, you are taking the unit vector for it. So just remember the formula. Formula is sufficient. because it's not out of the syllabus. So somebody can give you in your test, in your exam, this can be asked. Just write down this meaning, geometrical meaning. Then I'll start with cross product. Okay, that completes with the dot product. Coming to cross product task. Now, a small portion of cross product. Let me start today. I know it will be a lot to understand because already a big topic dot product we have completed. But let me just give you the brief one. At least the polar form will be easy. See, in the polar form, what do we do? When you have A cross B, you write the magnitude of A, magnitude of B, but you write sine theta here. Sometimes you will find that A cross B is written with A, B, sine theta, and an n cap is present. So sometimes this n cap is present to show the direction. Okay, direction of A cross B. Like your torque. Torque is a vector quantity. And see, here the result will be a vector. Like, I'll give you an example. Force is a vector, cross, not this opposite one. R. Displacement, right? Position vector, cross, force vector. Okay, this gives torque. All these quantities are what? These are vectors in nature. This is a vector, this is a vector, and resultant is a vector. And any cross product you take, resultant will always be a vector. So n cap is sometimes present to give the direction of A cross B, which is given by right hand thumb rule. But yes, this is not a standard way, okay, to solve every question. For every topic, you will be taught different methods how to calculate direction. Okay, so focus on that different method. This is just a general term. You generally just write it for the sake of writing. But for every term, how we write the direction of torque in class 12, you have whole magnetism, which is just based on your right hand rule and all. So don't worry about the direction. For every quantity, you will learn easiest way to remember the direction. And here, at least with me, you will just need your one hand, and right hand will be sufficient for all the directions. You don't require Fleming's left hand rule or anything. Just one hand is sufficient. And in class 11th, even that much is not required. Directions part is lesser. Actually, in class 12th, you'll have magnetism. In magnetics, you have those rules, no, Fleming's and all. So that time much directions concept is required. Here, it will be just given by logic. Now, resultant a vector, you have various quantities. Various quantities are present. Position vector, cross. Momentum will give you the angular momentum. Various things are there. I'm not writing the examples because it will just confuse you. With time, when you will have the things in the chapter, it will become clearer. Okay. And it is anti-commutative class. Nobody is going to write this. A cross B is equal to B cross A. This is invalid for this. That's why I erased. I by mistakenly wrote F first in this example here. I didn't write it as F cross R because it will change the entire meaning of it. So R cross, if it is R cross F, it has to be R cross F. I cannot change, you cannot change while writing. In dot product, you are free to write. Like your addition, and here like your subtraction, it is anti-commutative. And for parallel vector C, for parallel vectors, what you do, I cap, j cap. Here you have sine theta. So here these will be 0 this time because sine 0 will be 0. So this time the parallel vectors I dot I is equal to j cap dot j cap, I cap dot I cap equal to j cap dot j cap equal to k cap dot k cap will be 0. Reason is that theta is 0 between them, but this time we are not considering cos theta. That will make it 1. This time we are considering sine 0, which is 0. So that's why parallel are 0. But perpendiculars are non-zero, that's obvious. But how to write them? That's not 1 this time. Like there it was 1, here it won't give you 1. Though your sine 90 degrees 1, but there is another method to write all this that I'll tell you later. First, you write down till the three properties. First, tell me, are the three properties clear properly to both of you?
Yes, ma'am.
Yes,
Yes.
ma'am.
Okay. All right. Okay, then I'll stop here today. In the next class, I'll continue with this perpendicular one and how to solve cross product. And after that, we'll straight away come to the chapter in the next class itself, because just cross product and then angular. I'll start with first the angular projection, and then we'll do the horizontal projection. Okay. All right. Then.
Okay, ma'am.
One
Thank
more
you,
thing.
ma'am.
I didn't discuss the test paper also with you, no? Okay, in the next class I'll discuss that. The weekly test which happened, the motion in a straight line, that paper also is left. You both did some mistakes in one or two questions. That discussion is left. Next weekend, I don't think so we'll be able to have our class, because it will be an off, no, due to 7th and 8th.